Well, good afternoon. Welcome to NASA headquarters. My name is Dwayne Brown with the Office of Communications. Today, you will hear about NASA's next mission to Mars, the first mission devoted to understanding the upper atmosphere of the red planet. We'll have brief presentations, then open it up for questions starting here in Washington, our NASA centers, and the phone line. And you can send your questions in at the hashtag AskNASA. Of course, follow the conversation, and when you talk about Mars, there's a lot of excitement and a lot of people talking about this mission. Join us on Twitter, Facebook, YouTube, and other NASA social media sites. And of course, all of the information you hear today and much, much more is on the web at www.nasa.gov/MAVEN. Before I introduce you to our briefers, to provide opening remarks, ladies and gentlemen, please welcome the Associate Administrator for the Science Mission Directorate, John Grunsfeld.
Thank you very much, Dwayne. Our exciting mission for science at NASA is to unravel the mysteries of the universe. No other planet, other than perhaps Earth, has held the attention of people around the world than Mars. Of course, those are all the planets that we've discovered. There may be one yet. But for now, it's been the inspiration for legions of science fiction authors and for many scientists who thought they were doing science but turned out to be science fiction. That's the process of science. With the great discoveries from our robotic explorers and most recently Curiosity on Mars, the mystery of what happened to Mars' atmosphere is indeed a mystery yet to be solved. MAVEN, the Mars Atmosphere and Volatile Evolution mission, is designed to do just that, unravel the mystery of the past and present history of the Mars atmosphere. A MAVEN is a trusted expert based on accumulation of knowledge who seeks to pass that knowledge on to others. MAVEN, like its entomological origin, will indeed establish the knowledge on which scientists can build a story of the Mars atmosphere and help future human explorers who journey to Mars and to the Mars surface. The MAVEN team has done an exemplary job getting us close to the launch pad. However, these journeys are never easy. Just earlier this month, the team hit a potential showstopper with the shutdown of the federal government. Given the extreme importance of the MAVEN spacecraft as a future communication resource at Mars for our assets on the surface, we were able to keep MAVEN processing towards a launch on November 18th. I'm thrilled to be here today so we can update you on all the launch preparations for MAVEN and about the great science that it will do. Thank you, Dwayne.
Thank you, John. Now, let me introduce you to today's briefers. First up will be Jim Green, Director, NASA's Planetary Science Division, NASA headquarters. Lisa May, MAVEN Program Executive, NASA headquarters. Kelly Fast, MAVEN's Program Scientist, also at NASA headquarters. Bruce Jakosky, MAVEN Principal Investigator, University of Colorado Boulder, Laboratory for Atmospheric and Space Physics. And David Mitchell, MAVEN Project Manager at NASA's Goddard Space Flight Center in Greenbelt, Maryland. And with that, Jim, I'll toss it to you.
Thank you very much, Dwayne. May I have my first graphic, please? What we're seeing here is an overview of our Mars missions within this next decade. We see several operational missions. These are our orbiters, and 2 of our rovers are still moving well on the surface. Our orbiters, Mars Odyssey, the Mars Reconnaissance Orbiter, and the ESA's Mars Express are doing a great job continuing to map the surface, look for potential sites for future missions, but also giving us a window into some of the past regions where, for instance, Curiosity has landed. We see from Curiosity observations that it's landed in an ancient riverbed. This tells us right away that Mars had a much thicker atmosphere and was much more like Earth in terms of a blue planet than it is currently today, a very dry on the surface planet. Curiosity has also told us a lot about its atmosphere. It tells us that perhaps as much as 85 to 95% of Mars's atmosphere has changed over several billion years. How that's happened is quite the mystery. And that's where we get to MAVEN. We're all very excited about the upcoming launch of MAVEN. And November 18th is when the window opens. MAVEN will begin to look at those processes that tell us what's happened to Mars's atmosphere and why Mars perhaps underwent a major climate change in its past. For the rest of the decade, we have several orbiters planned, in addition to a couple of our landers. And in fact, we're working hard for our next Mars 2020 rover, which will be based largely on Curiosity's structure. So with that, I'd like to now turn it over to our program executive, Lisa May, who will talk about the MAVEN team. Lisa?
Thank you, Jim. About 5 years ago, a little more than 5 years ago, MAVEN was selected as the second Mars Scout mission. Mars Scout missions, like Discovery missions, are what we call PI-led. And that means a principal investigator, in this case Bruce, has to pick science objectives that are compelling. They have to develop an approach that's credible and assemble a qualified team. And it's appropriate at this juncture to look back and look at Bruce's choices and our decision to select MAVEN as the Mars Scout mission and recognize how very well that has turned out. This team, which consists of the University of Colorado at Boulder, Goddard Space Flight Center, the University of California at Berkeley, Lockheed Martin and JPL, along with the United Launch Alliance and the Launch Services Program at Kennedy Space Center, has performed excellently. They are on schedule, they are on budget, and they are on track to launch at the beginning of the launch period on November 18th. It's very exciting and quite a privilege to have worked with them these many years and to be here at this most visible milestone on their journey to Mars. And when they get to Mars, when MAVEN gets to Mars next fall, it will do some amazing science, as Jim has alluded to. And to describe a little more about how that science fits into our overall science program here at NASA, I'd like to turn you over to Dr. Kelly Fast. Kelly?
Thank you, Lisa. It has been and it will be an exciting few weeks in NASA planetary exploration. The LADEE mission just recently went into orbit around the moon, and soon it will begin studying the environment of the moon. Later on, we're going to even have the Venus spectral rocket, which will take a peek above Earth's atmosphere to take a look at Venus's upper atmosphere. And then in between, we have the MAVEN launch, and it's just been a pleasure to see the MAVEN mission come together. And so MAVEN is a planetary mission, but it really cuts across, the science that MAVEN will be doing really cuts across all of NASA's science disciplines, as shown in this graphic. MAVEN will be studying processes that led to the escape of much of Mars's atmosphere, but those processes actually are driven largely by the sun, and so the study of the sun, heliophysics, figures very prominently into MAVEN science. Those processes are also active in Earth's environment, but under very different conditions and with a very different outcome. And so that falls within the realm of Earth science. And then these processes are also players in the interaction between other stars and their own planets, an area of exoplanet research in astrophysics. And so this science really does cut across NASA science disciplines, but the next step in the study of that science is MAVEN. And with that, I would like to pass the microphone to MAVEN's principal investigator, Bruce Jakosky, who's going to continue to tell you about the MAVEN science, all the details and further details about the mission.
Thank you. It's clear that major questions about the history of Mars center on the history of its climate and atmosphere and how that's influenced the surface, the geology, and on the possibility for life. MAVEN is going to focus on trying to understand what the history of the atmosphere has been, how the climate has changed through time, and how that's influenced the evolution of the surface and the potential habitability, at least by microbes, of Mars. What I'd like to do is tell you a little bit about the science and then about how we're going to achieve the science. Can we go to the first video, please? We're looking here not at the Earth, although you might think so, but at an artist's rendition of early Mars. An atmosphere thick enough to hold water, water clouds. On Mars, we know that these things happen, that water flowed over the surface because of geological and geochemical features that are present on ancient surfaces. But somehow, that atmosphere changed over time to the cold, dry environment that we see today. One that is too cold with an atmosphere too thin to be able to support liquid water. What we don't know is what the driver of that change has been. There are two places that the atmosphere can go. It can go down into the crust, it can go up to the top of the atmosphere and be lost to space. And I think these questions of where did the water go, where did the CO2 go from that early atmosphere are driving our thought, driving our exploration of Mars. What I'd like to do is talk a little bit about some of the mechanisms for climate change, and in particular, how the atmosphere might have been stripped away by processes driven by the sun. There are a lot of processes that we think may have played a role, and we don't have the measurements to understand them today, but we've got an idea of how some of them work. Can we go to the second video, please? We're going to see a simulation of the ability of the sun to strip away some of the atmosphere. We're looking at a model simulation of the upper atmosphere represented by the colors with the arrows showing the solar wind. And you can see that as the solar wind sweeps by, it is able to strip off the atmospheric gas. It looks like it's flowing off here, but it's actually stripped away molecule by molecule, atom by atom. Now, this is only one simulation of how this process might have worked, and it's only one of the many processes that might have operated to take gas out of the atmosphere and remove it to space. But it shows very graphically what we're trying to measure with the MAVEN mission. The next graphic, please. We selected a suite of instruments in order to make the measurements that will tell us what's going on. And we have 8 instruments. They're shown here as 9 sensors. The instruments in the upper left are focused on measuring the energy input from the sun, the solar wind, the solar storm events that can blow material out, the solar EUV radiation, EUV photons. All of these can hit the upper atmosphere of Mars and through a variety of processes strip away gas. With these instruments, we have the ability to measure what's going on, to understand what these processes were and how they operated. These 5 instruments along the bottom are focused on understanding the structure and composition of the upper atmosphere and how it responds to the solar energy that hits it in these different formats. I wish I could tell you about each of these instruments, but I think we would be here all afternoon because there's a lot to talk about on each one of these, and I hope we'll have that opportunity coming up. These instruments are on the MAVEN spacecraft, which also was designed to allow us to get the measurements we need over the course of the mission. So hopefully these instruments will give us the data that we need in order to answer the questions that we've posed. Now, in addition to the science instruments, we're also carrying an Electra relay communications antenna and radio. This allows us to continue the ability to communicate with the rovers on the surface by sending the data through one of the orbiters. We'll be able to provide that function for Opportunity and Curiosity that are on the ground today, and into the future for InSight and for the Mars 2020 rover that will launch in 2020, remarkably. I'd like to go on to the next graphic. We've had a vigorous outreach program to bring the results of the mission to the public. Now, we haven't launched yet, but we've had a vigorous program leading up to launch. We've collected names of over 100,000 people that we'll be sending to Mars. These are names that people submitted to us because they want their names to go to Mars. In addition, we've had 2 contests. One of them was to send haiku messages to Mars. We had over 15,000 entries in that, and the public selected the winning entries that will fly to Mars. And then shown in the graphic at the top here is the winning entry off of the public art contest. This one was submitted by a classroom of, I believe, second graders, where each ball is the planet Mars, and they affixed to the planet the things that they want to take with them when they go to Mars, and took a picture of it and submitted it as their winning entry. All of the winning entries are going on a DVD pictured in the lower left that will fly on the MAVEN spacecraft. The arrow points to where on the solar panel it will go. And just last week, the flight DVD, we actually had a test DVD as well. The flight DVD was affixed onto the spacecraft. You can see that in the lower right. It's on the back side of the edge of the solar panel. We have a really exciting mission. I'm looking forward to getting to Mars about a year from now, a little under a year from now, and being able to do our science mission. I have to tell you, it is so thrilling to be able to look at launch only 3 weeks away from today. At this point, I'd like to turn it over to our project manager, David Mitchell from Goddard Space Flight Center, who will tell us about the process of getting the spacecraft and instruments here.
Thank you, Bruce. For starters, I want to take a step back. I am going to talk about the team a bit and the milestones that we've achieved and the milestones going forward. But taking a step back, as Bruce mentioned, we're just 3 weeks away. We're on the doorstep of going to Mars, and this has been a journey of 10 years. We were selected 5 years ago, but Bruce and a couple others put together from a clean sheet of paper the idea back in 2003. So it's amazing now at this point after 10 years to be on the threshold of heading out to the red planet. So anyway, I'll talk a bit about some of the events that have happened. Certainly, it's been years of work just building proposals and building the designs, and starting with the instruments and the boxes and assembling the spacecraft. Over the past year, the team has been engaged in putting it all together and going through extensive testing of the system, leading up to when we shipped to Cape Canaveral from Denver in August. So there's been a lot of work on that point. What I'm particularly proud of is the fact that when we submitted this proposal 5 years ago, we picked a certain date that we wanted to be launch ready. It was November 18th, 2013. And by golly, we're close. I mean, we're 3 weeks away, and everything is on track for us to actually be launch ready. And of course, weather and a lot of other things could steer us a little bit there, but really, really proud of what the team has done so far. But then on the other side of it, this is really just the beginning. We're finally going to start flying to Mars, so there's a long way to go. And I've always said to Bruce, and he back to me, that we're never a success until we're at Mars and we're taking data and getting the science that these folks envisioned back in 2003. So Lisa mentioned the teaming, and I want to say it one more time because it's so important what this group has done. The University of Colorado, the Goddard Space Flight Center, Lockheed Martin, Berkeley out at the University of California, and the Jet Propulsion Lab. From a spacecraft teaming standpoint, it has been such a pleasure to work with this group. On the launch vehicle side, and I'll show a couple of videos in a moment, but the Atlas V team, what a track record with that launch vehicle, and with the United Launch Alliance, with the Kennedy Space Center Launch Services Program, and the U.S. Air Force 45th Space Wing, the group down there at Cape Canaveral Air Force Station. So really, really excited to be at this point. So I will go now to the video, if that could be rolled. In just a couple of minutes of activities I wanted to point out. This is a fast-paced view of the spacecraft being loaded into a C-17 aircraft. Now it was leaving from Buckley. Now it's landing at the shuttle landing facility at the Kennedy Space Center, and now the spacecraft is coming out of the C-17. This is our spacecraft as it just arrived at the PHSF at the Kennedy Space Center, being lowered onto a ground support stand. And here is a test that was actually done in Denver, but repeated again at the Kennedy Space Center. And it's a solar array deployment. This is the wings being deployed and ready to fly. I mean, this is how it'll look just a few minutes after separation from the Atlas vehicle 3 weeks from now, we hope. So it'll fly in this configuration all the way to Mars. So Very exciting moment to get to this point and show it everything operating as planned. And as you'll see in a minute, a happy group there cheering it on. The next shot, actually, this test occurred last week in Florida at the Kennedy Space Center, and this is spin balancing of the spacecraft. And the properties were so well done that they only needed 8 pounds of ballast to get it where they needed to. So this is spinning at about 5 RPM. This is the Delta Mariner ship that takes the booster and the Atlas Centaur from Decatur, Alabama, where it was built and brought out to the launch site. And there it's making its way over to the launch site. And this, of course, is what we're all about here. This is just an animation, of course, but this is what in September of next year we hope to be orbiting Mars, and we fully intend to. And it's been a great journey so far, and we got a long way to go. And but we're on track. I just wanted to mention a couple of other quick things. One is that we launch on November 18th, and we'll be in Mars orbit insertion September 22nd of 2014. And on the operations side, the ops team has been working and testing and stressing the system to make sure we've got it all in line, and they've really worked very well together, and we're distributed around the country. So a great ops team, they're ready to roll, and as a whole, our team is excited and get ready for the next part of the journey. So with that, I'll turn it back to Dwayne.
Okay, thank you. Well, ladies and gentlemen, before we take questions, I've had the opportunity to work with many, many teams in the science arena, and these guys are good. Let me tell you, Bruce Jakosky, did I get that right? I got to get the boss's name right here. And I know lots of folks watching this program, particularly the folks down in Florida. We're coming down, and thanks for all you do down there in Florida, getting the spacecraft ready. You can send your questions in, again, on hashtag #AskNASA. Follow us on Twitter, Facebook, YouTube, other social sites. So what we're going to do, we're going to start out with the phone lines first, and then we'll toss it to my colleague, Jason Townsend, who is manning the Ask NASA site. Send those questions in, and let's go to the phone lines, and I believe we have Peter King from CBS.
Good afternoon, y'all.
Yes, Peter, go ahead. Okay, we'll get Peter back. We lost the connection. Camille Carlisle, are you on the phone? Going once, Camille. Okay. All right. Well, let's go to. Let me go to my colleague Jason, and we can get back to the phone line. Jason, what you got going over there?
Indeed. We're monitoring all of our social networks here for questions from the hashtag #AskNASA. So first one up here comes from Marcia Smith. What international participation, if any, is there in MAVEN?
Let me address that. We have two components of international cooperation. The first is from one of the groups in Toulouse, France, which provides hardware for the SWIA instrument, the Solar Wind Electron Analyzer. That instrument is built jointly between Berkeley and the IRAP group, I'm not going to get the French right, but Research Institute for Astrophysics and Planetary Science. The instrument is jointly done between the two groups. In addition, we have several other investigators in France who are participants on the science team. On the spacecraft side, Dave, do you want to talk about the international components from the spacecraft?
Certainly, there's multiple elements that come from Germany, Italy. I'm trying to click through the others, but there certainly is. They're primarily subcontractor vendors through Lockheed Martin, different elements of the spacecraft that are provided from European locations.
Wonderful here. We've got two questions that kind of dovetail into one another here. The first is from Siba. How could findings from the MAVEN mission help future manned missions to Mars? And the second one from Allison Wilgus asks, how will data from MAVEN help us improve our models and plans for human scaling, entry, descent, and landing on the surface?
Let me address both of those again. On the entry, descent, and landing, For spacecraft like the rovers that we've been sending recently, they're only very slightly sensitive to this part of the atmosphere. They really begin to sense it at about the altitudes we're studying, but they're not as important. The possibility where they come into play a little bit more is when we send human missions where especially if we're using passage through the atmosphere to slow down the spacecraft, we want to understand what the structure, the composition is at all parts of the atmosphere, including the upper atmosphere.
Okay, let's go back to the phones and see who we have on now. I believe Reuters. Irene, are you with us?
I am, Dwayne, thanks. Can you hear me all right?
Yes, go ahead.
Good, thank you. I have a few different questions. First is, this is probably for Bruce. It sounded from the description of the mission that this is very much a cumulative process. There's not going to be science coming out on a kind of a regular basis like we get with MSL as it goes to different sites and things. If you could just maybe address that, and also the primary mission duration and the program costs.
On the first one, it is a cumulative mission in the sense that we need the data from all of our instruments working together in order to get the science results. And we're anticipating that we'll really begin to get our first key results at answering the questions we've posed after about 3 months. We picked the mission duration of 1 Earth year because in that time, at this timing in the solar cycle, we expect there to be enough variability of the sun, enough solar events that we'll really be able to get a handle on what's happening. So we picked that mission duration. Now, even despite that, despite requiring integrated data, we do anticipate putting some data out very quickly. We're hoping some cool images of the planet as we start to collect data. And it's very hard to anticipate discoveries you're going to make until you see them, but when we do, if we do, we will get those out very quickly. Lisa, on the program cost?
Yeah, on the program cost, MAVEN as a Mars Scout, like Discovery missions, has a cost cap, and when we confirmed MAVEN, it was at $671 million for the life cycle all the way through that Earth year of operations, and they are doing very well in that respect.
Okay, next on the phone, Ken Kramer from Universe Today. Ken? Going once, going twice. Ken, are you with us?
Yes, hi. Can you hear me now?
Yes.
Okay, good. First, let me just say good luck through the launch. My question, I have a couple questions, one for Bruce and then one for Jim and John Grunsfeld. For Bruce, can you mention if there is any methane any capability to detect methane with this at all? And I'm also wondering, we have the Indian Mars MOM mission coming up soon, has a few similar objectives. Have you held any discussions with that team? Thanks.
We do not have the capability to measure methane or any of its chemical byproducts. In putting the MAVEN mission together, we wanted to focus on specific questions that dealt with escape of the atmosphere, history of the atmosphere over time, and as important as understanding the role of methane is in the atmosphere today, especially as a possible indicator of life, we just had to leave that one off in order to stay focused and stay within our available resources. With regard to the Indian mission, we have had some discussions with their science team. There are some overlapping objectives. And at the point where we're both in orbit collecting data, we do plan to collaborate and work together with the data jointly. We just have not gotten that far yet in our discussions.
And Ken, you have a question for Dr. Grunsfeld? He's okay. All right. Let's go back to social media.
Sure. Our first question comes from Clara Moskowitz. How different are the MAVEN instruments from instruments that have flown on previous orbiters?
So the question, in case you couldn't hear that, was how different are the MAVEN instruments from those that have flown on previous orbiters? Let me answer a little bit more broadly than that, because the instruments that we're flying have generally flown before somewhere, either in Earth orbit, studying some of the same processes there, or some of them have actually flown at Mars. This is the first time we will have flown all of these instruments in one package so that we can really get a comprehensive look at the Mars upper atmosphere with all of the measurements made simultaneously.
Wonderful. Our next question comes from OmniComment. Could you elaborate more on the competing science models for the loss of atmosphere that MAVEN is going to test?
Let me give a try at that, and I'm not sure if this is answering the question, but the driver is that the atmosphere of Mars must have been thicker in order to have been warmer and wetter. A thick CO2 atmosphere, is, for example, is the easiest way to get greenhouse warming to warm up the planet early in its history, especially as the sun was 30% dimmer at that time. The question has been, where did the CO2 go and where did the water go? There's a lot of evidence that some CO2 has gone to form carbonate minerals, that is, minerals that contain CO2 that are present within the crust. We've detected them from a number of different spacecraft observations from Martian meteorites that have been collected here on Earth. What we don't know is how much of the CO2 from an early thick atmosphere is retained in the crust. It's very hard to get a global inventory of the total amount of carbon within the crust, but so far we just don't see a large enough inventory to explain the early thick atmosphere. The other way to get rid of it is for it to be lost out the top of the atmosphere, and we have measurements that tell us that this is an ongoing process today, at least at a low level. We have measurements of isotopes in the Mars atmosphere made most recently from the Curiosity rover that tell us that escape to space has occurred. And the European Mars Express mission has detected some of these atoms directly that have been lost. What we don't know is how much loss has occurred through time or how the processes that control it operate. So MAVEN is designed to provide not just the measurements that tell us about loss to space, not just that it has occurred, but to let us determine how much has occurred over time and what processes have controlled it. So what we're trying to do is to determine the relative significance of these different processes by looking at the one that has been completely ignored so far.
Okay, we'll take one more question, and then we're going to try the phone lines again. We're having some connectivity issues, but they're addressing those. One more question here.
Wonderful, then. These two questions kind of dovetail exactly together here. First comes from Steel Toad. Will MAVEN collect data or images during the journey to Mars? And then Hannah Bird asks, is there any opportunity for the public to analyze any of the MAVEN data?
During the cruise, we have a 10-month cruise phase to get to Mars, and the primary focus there is going to be on testing the instruments, making sure they work, doing calibrations in space. But in doing that, we will get some observations along the way, particularly of the solar wind and the solar hydrogen corona permeating interplanetary space. In terms of public analysis of data, our plan is to put the data out to the public through the Planetary data system. That will happen as soon as we have the data well understood and calibrated. At that point, it's available to everybody.
Okay, let's see if we can go back to the phone lines and see if we have Peter King that rejoin us. Peter? Peter King or Dan Vagano? Dan.
Hi, folks. This is Dan Vergano with National Geographic. I have two questions. One is, what's the launch vehicle cost on top of the $671 million? And the second is a scientific question. I'm trying to understand if Mars's magnetic field is varied over time. How can you be confident of what loss you're seeing now is reflected in results, or your results now will reflect what was happening way back in the past?
Hi, Dan. This is Lisa May. The launch vehicle cost is included in the 671, and it's approximately $170 million.
On the science question, We have measurements from Mars Global Surveyor of the crustal remnant magnetism that tell us that Mars had a magnetic field at some time in its past. The role of the magnetic field here is that if you have a global field, it causes the solar wind to stand off. It pushes it away so it doesn't hit the upper atmosphere. It isn't able to strip off the gas out the top. So the turn off of the magnetic field would have allowed the turn on of stripping of the atmosphere by the solar wind. And we know that the magnetic field turned off partly because we don't measure one today, and partly because the crustal remnant magnetism, the regions that retain that magnetic field, is limited to the surfaces about 4 billion years old and older. The younger surfaces generally don't have a magnetic field imprinted on them that would have indicated the presence of a magnetic field.
The next question from Camille Carlisle from Sky and Telescope. Camille?
Hi, can you hear me?
Yes.
Excellent. So my question is for Bruce, and I was wondering, one of the ratios talked about in MAVEN studies is the deuterium to hydrogen ratio. I was wondering if you can explain how can you relate that ratio in Mars's atmosphere to what happened to the water?
Okay, the deuterium to hydrogen ratio comes into play as follows. Hydrogen and deuterium are the same element. Deuterium is just twice as heavy as hydrogen because it has an extra neutron in the nucleus. What that means is that as hydrogen escapes, hydrogen and deuterium are both light enough that they can float up and escape out the top of the atmosphere. The lighter hydrogen escapes more efficiently than the heavier deuterium. So as escape continues, more hydrogen is lost, less deuterium. The ratio of deuterium to hydrogen of what's left behind then increases over time. The source of either the D or the H is water out of the atmosphere. It's broken apart by sunlight, and that frees up the hydrogen or the deuterium so it can float to the top and escape. Ultimately, what's left behind can get reincorporated back into water, so you can measure that D to H ratio either in the water or in the hydrogen at the top of the atmosphere. But by measuring that ratio, you can directly infer what the escape to space has been. The ratio as measured in some of the meteorites that come back from Mars and in some very limited measurements at the top of the atmosphere suggest a ratio of about 5 times the terrestrial value, and that means that somewhere in the range of 85 to 90% of the hydrogen that was there must have escaped, and that means that 85 to 90% of the water that was there must have been broken apart. The hydrogen escaped and the oxygen sequestered somewhere.
Okay, let's, I believe Irene from Reuters has a follow-up. Irene?
I do, thanks. I'm not sure who would be best to answer this, but I was just wondering if someone could please go through the major milestones between now and launch day. Thanks.
Yeah, sure. This is Dave Mitchell. So this week we're in the process, well, I'll say late last week we fueled the spacecraft up, so all the hydrogen is on board. We are now this week going to go through attaching the interface ring, the payload adapter between at the bottom of the spacecraft, and then so that'll be secured, and that'll ultimately go on the upper stage, the Centaur interface of the launch vehicle, but that comes next week. So that interface ring will be attached this week. Then late this week, they're working on the encapsulation of the fairing, or processing, getting ready for that encapsulation, which will occur early next week. So that'll be the last time the spacecraft is visible as a whole. It's shrouded in this Atlas V fairing, and then if all goes to plan, very early in the morning, I think about 2 a.m. on November 6th, they'll start the slow process of driving the spacecraft and the fairing out to the launch pad. And so on November 6th, they will take it to the pad and hoist it up and put it on top of the rocket. So from that point, It's all about integrated operations in terms of the communications and the testing that'll happen between the spacecraft and the launch vehicle. And then as we get even closer, so about 10 days after that mate and a lot of ringing out of the system to make sure everything is talking as it should, we will roll the launch vehicle out to the final location for the launch. Just I don't know, a couple hour journey out to that launch pad, and then 2 days later we'll be ready to launch. Tomorrow, the team is involved with what's called on the launch vehicle side is a wet dress rehearsal, where they'll tank up the booster and the second stage, and check out the system, make sure everything is operating as planned, the valves and the telemetry, all the data points are all playing as planned. And so that's important, that if there's anything that's found in that operation tomorrow, we can repair it well in advance of the spacecraft moving out to the pad. So a lot of integrated activities over the next couple of weeks and getting ready for the launch on the 18th.
Okay, we're going to take a couple more questions from our public, and then we're going to go to the phone lines one last time. I'm determined to get Peter King from CBS to ask a question. A couple more questions from our public, Jason.
Sure. So Vladimir Kiefer asks, when will MAVEN orbit Mars if it launches in November? And Maxwell Taggart asks, how long will the mission run?
If we launch on November 18th, we arrive at Mars on September 22nd. We have a 20-day launch period during which we can launch. If we launch at the end of that on December 7th, I believe we arrive on September 26th. So late September we'll be arriving. We have a 5.5-week period in orbit in order to commission the spacecraft. That will be the time we get into our final mapping orbit, deploy all the booms, make sure all the instruments are operating, do the final tests and calibrations, and then we're ready to start mapping. We have a 1 Earth year primary mission, so that runs from about November 1st, give or take a couple of days, of 2014 to November 1st of 2015. And then we have enough fuel to continue perhaps for as long as almost a decade, doing a combination of relay and extended mission science. So we're hoping for a very long mission.
Okay. Peter King, I'm going to give you one last shot, my friend. We had time for a couple more questions. Peter, are you with me from CBS?
Can you hear me now?
There he is.
All right. I'm glad we finally got this resolved. I've got a couple of questions, one for Bruce and one for John Grunsfeld, and that'll give, I'll ask Bruce first, that'll give John time to get to the mic. Bruce, when we were in the clean room a few weeks ago down here at KSC, you and I talked a little bit about the possible shutdown, and the government shutdown only really affected you guys for a couple days. I'm just curious, did you lose anything terribly significant or meaningful in terms of the big picture? And how worried was the MAVEN team with this specter looming?
I'm going to let Dave answer the question about the impact on the team and the preparations.
Sure. So the shutdown, as everyone knows, occurred on October 1st, and so on that day we were in the process of safing all our systems. So that went well, and then within 2 days we were thankfully reactivated. So we lost a couple of days there from the standpoint of efficiencies and actual time down. But one thing about this team that has been incredible since day one is they rise to the occasion, rise to the challenges. And so extra shifts were added. We made sure we had the right people on board, extra people to do this safely. But we worked extra shifts over the weekends, second shifts, and they got right back on track in a matter of a week. So we're on our nominal pre-shutdown plan at this point. We're really doing well. So again, kudos to the team. But it's the uncertainty that's always hard. When are we going to be reactivated? But once we did, the team really stepped up and did well on it.
Peter, your question for John?
because, obviously the decision was made to continue work on MAVEN because it was time sensitive and there was an awful lot of money involved. But much of the rest of NASA was shut down for a good 16 days. And I'm wondering, with the projects that you and your division are involved with, what kinds of data were lost during that time? What kind of work was lost during that time? And is this anything that could be made up? And finally, future implications of all that. And now I'll be quiet and listen.
Well, thanks, Dan. The impacts to the shutdown are still being evaluated. Clearly, for those projects that were completely shut down and had no work going on, we're behind on those. In some cases, they're day-for-day slips. In some cases, they'll be much longer than that because conflict for resources such as test chambers, thermal vac chambers, vibration tables, all of that's still being evaluated. For the missions that are on orbit taking data, for the most part, those continued in operations, continued on their scientific missions. The data analysis stopped, but the actual acquisition of data, for instance, the Hubble Space Telescope, typically carries with it 2 weeks of observations in its own memory. So it continues as long as it doesn't get upset and go into safe mode or something like that. All of that data gets beamed down to the ground, and eventually the scientists will get that and work on it. So it's kind of a combination of things, but that's still an evaluation. There are some things where the science is just simply lost. We had flights of our airborne observatory, SOFIA. We lost 9 days of observations. Those could get recycled into the queue in some future years, but for the most part, those observations are lost and will have to be reproposed.
Thanks, John. Okay, we're going to take 2 more questions from the phone line. Dan Leone from Space News, and then Ken Kramer, you will have the final time slot here. So Dan, from Space News.
Yeah, hi, everybody. Thanks for having this event. Very helpful, very educational. I have a potpourri of questions, and anyone who likes can take them. First, what's the launch readiness review date for MAVEN? Second, would there be any consequence to science operations if you launch at the end of your window, which, and correct me if I'm wrong, is something like the 15th of December? And finally, regarding the sausage making of how you get the project turned back on during the shutdown, where at NASA was that decision made? How did you get a lot of people who were presumably out of work to coordinate and say, without wasting any time, we must restart this right away? How does it? Can you walk us through it? In any order is good for me. Thank you.
Well, this is Dave Mitchell. I can say launch readiness review date is Friday, November 15th, in advance of the initial launch capability of the 18th of November.
This is Bruce on the question of science impact of where we launched during the launch period. We had a nominal 20-day launch period from November 18th to December 7th. As we've gone through the development and the spacecraft came in a little bit lighter and the launch vehicle capability came in a little bit larger than originally assumed, we were able to extend that. So that's why you and I have talked about the December 15th date. We could actually even go a little bit later. But if we launch anytime up to about December 15th, we have the full science mission. There's no impact. As we get later than that, if we're not able to launch until a week after that, it takes more fuel to get into orbit, and that fuel comes out of the science mission. So it begins to have an impact. But certainly during the nominal 20 days or even the extended 27 days or so, where we launch really doesn't make that much of a difference. Obviously, the best place to launch, the best time to launch is right in the middle of the period, because that's when the energy requirements are the lowest and the fuel used would be the least, and we would have the most fuel for an extended mission. But we can do our full mission and extended mission anywhere during that period, and the estimates for longevity that we've talked about are all based on sort of the worst opportunity within that 20 days. Lisa or Jim?
Thank you. Yeah, relative to the planning process for an anticipated shutdown. That really started in the Planetary Science Division. We began with a contingency plan. In the event that there would be a shutdown, we began to pull documentation together. Lisa led that effort, did an outstanding job putting together the material that clearly demonstrated what our problems are with planetary missions that have a window and what would happen if we actually missed the window with MAVEN in particular. So that assessment was then brought to John, and John took that up to our administration and worked the process from there on. And in fact, a decision was made that if the furlough took place more than 2 days, then we would have the opportunity to restart the project. Okay?
Okay, last question, Ken Kramer, University Today.
Hi, thank you. I just wanted to follow up on my prior question. I think got lost in the garble. Maybe Jim Green just answered it, but I was wondering about the emergency exemption, exactly how that was done, who did that, was that easy or difficult, and also with the Indian Mom mission, is there any U.S. involvement in scientists or instruments? Thanks.
Hi. Yeah, I'll start with that. One of the important things that you might have not noticed in Bruce's last statement is that the amount of energy required to get into orbit at Mars varies, and we recognized that longevity for MAVEN is important not just for the science but for the relay. And we, as a Mars program, of course, count on all of our orbiter assets to relay data for the rovers. Currently, Odyssey and MRO are relaying all the data you see from Curiosity and Opportunity. And so as a program, we recognized a risk to the agency of not only missing the science that was poised to be done when MAVEN launched, but also of having a long-lived enough asset to provide us that communications capability. And that discussion happened at, as Jim noted, the planetary level, and then went up to the agency level. But the important thing is this team is so high performing that they absolutely knew how long they could tolerate a delay. And they provided us with very good information about what it would mean to their team to be able to restart after differing periods of time, and what it would mean to their mission and their mission lifetime, depending on when they launched and if there were delays. And so the agency had a lot of good data from the project to work with in order to set that decision. And the administrator level made that decision to have a waiting period because we knew this team could tolerate a bit of a delay and make it up as they did. And as for the MOM mission, the Indian mission that's about to launch next week, I don't believe we have any current science participation. I'll let Bruce talk to that more if he'd like. But we are actually supporting them with the Deep Space Network and tracking, and also some navigation support out of the Jet Propulsion Laboratory. So they've approached NASA, and we've agreed to provide that support, and that will be valuable for them as they send their first mission to Mars. And it's also valuable for us in able to collaborate and in order to track them as they arrive at Mars at approximately the same time that MAVEN does, in the same month that MAVEN does. Anything further, Bruce?
No, I'm not aware of any science collaboration or cooperation beyond what I mentioned earlier.
Okay. Well, ladies and gentlemen, before I close out, clearly you've heard some recurring themes here. The incredible science, incredible team, on budget, on schedule, and meeting any challenges. Please join me in giving this MAVEN team a round of applause for this outstanding work. Okay, the date is set, November 18th, 1:28 p.m. Eastern Time. We're going back to Mars, folks. We want to see you there. And of course, you can go to the website to learn much more about the mission and the updates at www.nasa.gov/MAVEN. We'll see you in February, Florida. Here we come. Go MAVEN team.